Action. Hello and welcome back to Calculus 1 Chain Rule Part 2. So we started with combining the rules, and we can have situation like this. The derivative of, let's say, a to the x over sine x. No. X squared plus 3 to the 6th power. Can I have that? So what are we going to do here? Do we all see the quotient rule? Yes, we all see the quotient rule. But you also see the chain rule here. So this one is quotient within the chain. That's what it is. Right? Right. So I have, again, this is what happens in my head. I don't know which way your head works, but my head works this way. I have x to the 6th. All right? So it's immediately 6 x to the 5. That's the way my head works. And then whatever is this is e to the x over x squared plus 3. So if I'm going to regard this as one big X, then that's that X. So you can see x to the 6 becomes 6x to the 5 in a derivative. And now times the derivative of the inside. The derivative of the inside is this quotient rule. So you take x squared plus 3 and square it. X squared plus 3 gets copied. The derivative of e to the x is e to the x. Minus copy e to the x, and then 2x here. Now we can kick e to the x outside, and we get 6e to the x, e to the x over x squared plus 3, everything to the 5th power, times, now we kicked e to the x out, we are left with x squared minus 2x plus 3, all divided by x squared plus 3, everything squared. Now look, you have the same denominators. This is again multiplication, but you have the same denominators, which means you can combine those powers, and then you have e to the x and e to the 5x. So what is the total over here? The total can be, denominator is clearly x squared plus 3. You have 5 on the left and 2 on the other side, so it's 7 of those. On the top you have 6e to the 6x, because over here you have 5e to the x's, because it's raised to the 5th power, and over here you have 1. So that's 5 and 1 is 6. And that's times x squared minus 2x plus 3. Now why did we do this? Because chapter 4 equal to 0, and then you solve this easy equation. What are the solutions for this equation if you set it equal to 0? You should be able to do this mentally without writing anything down. What are the solutions when you set this equal to 0? Well, 6 is not going to give you a solution. E to the 6x is not going to give you a solution. Denominator gets cross multiplied into 0, so it goes away. The only thing that gives you a solution is that quadratic polynomial, which you can see it factors into x minus 3, x plus 1. So solutions are 3 and negative 1 just by looking at this. And that's necessary for chapter 4. So you want to simplify. There is no way that you can set this row here equal to 0 and get negative 3 and 1. I mean, positive 3 and negative 1. Yeah. So simplifying is important, but we'll see some other things that happen here. Good. So that's the combination. You know what book is interested in? Book is interested in the second derivative of x cosine x squared. In order to find the second derivative, you have to find what first? First derivative, exactly. All right, let's see. All right, so what do we have? Well, I hope that you see this multiplication here, so we definitely have a product rule, and then we have to deal with the chain when we get there. All right, so what's the derivative? Y prime is equal to, copy the first derivative of the second, which is negative 1 sine of x squared times the derivative of the inside, which is x squared, derivative is 2x. Plus, copy the second, cosine x squared times the derivative of the first, which is 1. So let's simplify the derivative as much as we can. That's negative 2x squared sine x squared plus cosine x squared. Great. Now take derivative of that. So y double prime, which is the second derivative, is, this is the first. So copy the first, negative 2x squared, times derivative of the second is cosine x squared times 2x as a chain, plus copy the second, sine x squared, times derivative of the first, negative 4x. And then plus the derivative of this term, which is negative 1 sine x squared times 2x. Great. Let's fix this. I have negative 2x squared cosine squared 2x. And then this is minus 4x, and then minus 2x is minus 6x sine x squared. Oh, forgot the x over here. It's x squared, there we go. Much better. So what I can kick out is negative 2x. Hold on. I don't like this. The first term has this times this. So that's negative 4x cubed cosine x squared. There we go. Much better. And now we have minus 4x and minus 2x is minus 6x sine x squared. There we go. Much better. And now what I can kick out is negative 2x. And what's left? 2x squared cosine x squared plus 3 sine x squared. There it is. Second derivative. Lots of fun, right? It's not going to be a lot of practice, guys. You just have to be careful. Ready for the next one? Let's make it a last one for this. Find the equation of the tangent line for, now this is, it's a problem in a book. X squared minus 1 everything squared divided by x cubed minus 6x minus 1. So that's your function. At 3/8. Yeah, where's that procedure for tangent line when you need it? Yeah, I'm gonna go over there in hibernation. Guys, the most annoying part over here always is to take the derivative. So you do it, and then when you quit, you go mathematica, get it.
Nothing. I like how do you find? I took the snow covers the trees and stuff. I'm so everyone well, I thought sometimes. But let's say out of 10 times, he would shovel 9 plates 9 times. No, because look, he worked hard. He's 60 years old. And he worked at the recycling plant. He worked physical labor his whole life. He has using the next thing, so he comes to my place and we get in and talk, Chuck Norris, Schwarzenegger, Jackie Chan, like all the American involvement, like they're the pinnacle of everything for us. So, then he goes, where the people were talking in the bush 20 years ago, these guys are 3 days something. So he goes to his house and helps him with like all of the physical labor that has to be done in the house. He takes the dust with him. He was gratitude to drive into citizenship and go to drive license and everything out of me. One of those people, so I enjoy the company and we work together and we bring together the all because he came to the summer. So I was there for something more from us. They were he's 60 years old and he's still doing things. I don't need no more. So he can't sit. So when the snow is out, he just faces to the house. Put the movie on and text right now. Get bored. And then I wait like everyone else. I don't want to talk to him. He's out already. So almost every the entire winter, right? I shovel my clothes every other time. So the last winter, the last snow from 2 weeks ago, right? I get out, right, with a shovel, and everything is full. I'm talking about my driveway, my parking lot, my parking lot, up to the house, steps, everything done, right? Now he lives 4 doors away, right? So there was his house, his immediate neighbor, and then the fan goes away to my place, right down there, right? And then my parking and the fan into the house and everything around that, right? Now I'm out to shovel, and so I get, and I shovel in my neighbors, like the guy who lives next to me. I shovel that spot, because I have nothing to do, because these guys are doing everything. 2 years ago, they gave me, 2 years ago, I tutored my neighbor's daughter in high school, basic algebra and stuff. So he was very grateful, charging that for me, like, we walked and go across the street. So I charged him $25 an hour. No, they go to 50, 70. And he pays $25 an hour. So when the winter came, 2 winters ago, I looked at the window. He has that snow blower, what's it called? Snow blower, yeah. And he goes, so since the movie there was a time for me, my snow is twice, all the way but you and I also, we change brakes in cars. Listen, I'm not for car maintenance. He does his own oil. Yeah, you have to go back and drive. Driving the place for 15 minutes. 10 minutes. You drive. This is a car where I go. You drive over the pit, and they ask you to put the keys on the dash. And I leave the car, and in 10 minutes, I just threw the window, swipe my credit card, and sign, and leave. Come back an hour later. Let me get out of that. You know that there's that's too far. So the department store, that's Sunshine, is they're insane. $30 on the car. The car will and they have 3 of those beds. I've never been more than 15 minutes. You're driving and sitting in the car, and the tires, and they open the other I don't know if there's people want to see that. I thought that's the only one. Yeah, when you have anything special, you have to take Let's do the tangent line.
Okay, let's take a look at this tangent line and then do some lab problems. Take a look at your labs and call it a day. So what do we have here? Well, we have a function. The first thing we need to do is to take the derivative of this function so that we can find the slope. So the derivative is quotient rule with the chain rule embedded. So dy dx is equal to, we have denominator squared, denominator copied, the derivative of the numerator, which is 2x squared minus 1 times 2x as a chain rule, minus copy the numerator times the derivative of the denominator, which is 3x squared minus 6. Yay. Should we simplify this? Nah, just plug in 3 for each x. It's okay. We can compute from there. So just plug in 3, because when you compute the derivative, here's the new notation for you. This means take the derivative, and this vertical line means compute at, and then you write x equals 3. Compute at x equals 3. So that's your slope now. When you compute derivative at the point of interest, which is 3/8, you will get your slope. Now, good thing is they gave us 8. We don't have to compute that, at least, right? This is, thank you, right? Anyone writing the note? No? You're terrible people. You are. Don't kid yourselves, right? They gave you the y value. You don't have to compute it. So say thank you. Not to me, to author of the book. All right, so what do we do? Well, we have 3 cubed minus 6 times 3 minus 1 times 2 times 3 squared minus 1 times 2 times 3 minus 3 squared minus 1, everything squared, 3 times 3 squared minus 6 over 3 cubed minus 6 times 3 minus 1, everything squared. Now, slope equals, this parenthesis is 8. I hope that's clear. And then the other parenthesis over here is 8. So you have 8 times 8 times 2 times 2 is 4 times 12. Minus, that's 8 squared. And this is 27 minus 6 is 21. Divided by 8 squared. Oh, great. They all cancel. And all I have is 12 minus 21, which is negative 9. Yeah, exactly. So now I have that the slope is negative 9 and the point is 3, 8. Plug everything in. 8 equals negative 9 times 3 plus b. That's 8 equals negative 27 plus b. b equals 35. So tangent line is y equals negative 9x plus 35. If you change the point, like 3, 8, you change that point to some other location, then obviously everything changes. The derivative stays the same, but this 3 that you plugged in to get negative 9 would be your new number for x, which will give you a different slope, and all other calculations would be different. So that takes care of what we call chain rule. Chain rule is the way to take the derivative of composite functions, f composed with g, and then you've seen that we can chain 3 or 4 or more of these functions. They have the second derivative and the third derivative, so all of that exists as well. And also procedure for the tangent line. Again, that's going to be there in every section we cover, because we are learning how to compute the derivative in different ways, and to find the slope is just to compute the derivative. So we can do the tangent line problems as well. We will obviously revisit this next class again. Maybe I should bring in a little pop quiz or something like that. So we can, that would be a good thing for you to get that adrenaline going, right? It will count only if you have a bad grade on it. If you have a good grade, it doesn't count. It's one of my methods that I carry from my previous teaching experience. It's very effective. So it counts if it's bad. If it's good, it doesn't count. Good. So that's that. Let's take a look at the lab.